Hi everyone, my name is Thomas Kim. Today is November 27th, 2019. This is my first episode about programming techniques. In this episode, I will discuss problem solving strategy and we need a paradigm shift. When we learn programming, we learn how to use loops, iterative loops. But most of the algorithms can easily solved using recursion. Recursion is in fact much simpler than iterative loops. Through this series of videos, I will explain how to use recursion and iterative loop together to solve our problems. We need a paradigm shift in the way we approach to our problems. I listed 7 steps from step 0 to step 7. So it is 8 steps, but in case of step 0, I cannot help you much. Step 0, we have to recognize our problems. This step is the most challenging part. Sadly, I cannot help you much with step 0. My advice is to associate with people from diverse disciplines. For instance, if you are a student of physics learning computer programming, then associate with students, teachers, professors majoring in computer science, mathematics, chemistry, electricity, mechanical engineering, architecture, civil engineering, even biology and/or chemistry, etc. Step 1. Analyze our problems. Find a way to reduce a problem of size n to a problem of size n-1, n-2, or n-1 and n-2. Step 1. Analyzing our problem is the most important step in our problem-solving strategy. Step 2. Nature is recursive. Please remember it. Nature is recursive. Forget about iterative loop. Think recursively. Always think recursively. Recursion is simple and inherent in nature. Step 3. Implement the result of our analysis as step 1 and step 2 above to a working sequential algorithm by reducing the problem of size n to the problem of size n-1 or n-2. Through this step 3, our problem is solved using recursion and/or together with the iterative loop. Understand that, but for simple algorithms, we have to use both recursion and iterative loop together. Step 4. If possible, turn our recursion to iterative loop. Significant number of our problems can be easily converted to iterative loops. Step 5. Sort out parallelizable paths from the sequential algorithm. Then rewrite our sequential algorithm to parallelizable sequential algorithm. Turn the parallelizable paths to parallel, leaving sequential paths sequential. Step 7. Do profiling. Take advantage of cache techniques. By cache techniques, I mean both hardware cache and software cache. For some algorithms, software cache is more important than hardware cache. I will talk more about hardware cache and software cache throughout this series of videos, programming techniques. It might sound a little bit overwhelming, but don't worry, we will follow these steps all the time. I will give you ample examples until you completely understand these steps. To follow this session, you have to install C++ compilers and make some environment settings. Please double-click this link and watch this video to install C++ compiler and make proper environment settings. By watching this video, you have to create command prompt like this. Now start your File Explorer and move to a working folder or create a working folder. I will create new folder, Programming Techniques. Double-click the folder, copy the folder path, start Visual Studio Code, go to File, Open Folder, paste the folder path, select Folder. Then folder will be open like this. Right click your command prompt, right click, Properties. In the starting field, Ctrl A, Ctrl V, paste the folder path, click Apply, click OK. Click New Folder, 01, Motivation. Hit Enter. Click this button again, Summation. .cpp, hit Enter. Ctrl V, include IO stream, int main, void test summation. I will copy this function name, paste it in function main. Now here, step 1, analyze our problem. So I want to create a function like this. Sum 1 equals 1, sum 2 equals 2 plus 1, and sum n minus 1 equals n minus 1 plus n minus 2 plus 2 plus 1. Then sum n equals n plus n minus 1 plus n minus 2 plus 2 plus 1. From this analysis, we can conclude like this. Base case is sum 1 equals 1. Induction part is that sum n equals n plus, please note that this part is sum minus 1, so sum n minus 1. Okay, this sum n minus 1 is this part. This is called induction part or recurrence relation. So in step 1, we analyzed our problem like this. Now step 2, implement our analysis to a recursive function like this. The simplest approach is something like this. int sum, int n, if n equal 1, then return 1. This is base case, base, else return n plus sum n minus 1. This is induction part. Induction. So this part is this part. Okay, with this, we can test this function like this. I will define auto, cout, std, cout, auto, and there I defined these two things. Cout sum from 1 to 10 is sum 10, and there. Okay, now start command prompt, dir cd 01 motivation. Then we are using Clang compiler, Clang++, std, C++17, summation.cpp, hit enter, cls. So this is the result of our program. In the implementation of function sum, base case should always precede induction part. Base should always precede induction. This is very important because our problem in this case is very simple. We can just implement like this. But when our problem becomes more complicated, we cannot implement like this simply. For example, namespace hidden. We create an internal function like this, void summation intn int. This is reference result. Okay, if n equals 1, result plus equal 1, we can return here because this is function returning void. Else result plus n return. Okay, or we don't need in this case return. I will just remove like this. And we have to call summation n-1 result. Okay, this is recursion. We are calling this summation recursively. Okay, now in public interface int summation intn, we first initialize int result 0. This is initialization. Then we call this function inner interface hidden summation and result. Okay, then return result. When our algorithm becomes complicated, we have to follow this method. So initialization, call the computation, then return the result. Okay, this is for more advanced algorithm. We need this kind of approach. We create two functions. One is hidden function or worker function. Then this is a public interface. The worker routine, the public interface function. With these two implementation, void test advanced implementation. Then I copy this, copy, paste. Now it should be summation. Okay, we are calling this public interface. This public interface calls inner interface or the worker routine. Now I copy this function, copy, paste it in function main. I disable this part. In the command prompt again, we build again CLS. The result is of course the same. Some of you may argue that this problem is so simple that we can simply use algebraic solution such as sum n equals n times n plus 1 over 2. I know this algebraic sum solution is simple and elegant, and I also agree we have to use this algebraic solution. But in real life application, the window to the algebraic solution is very narrow because we are trained to find algebraic solution from elementary to college. Many people have wrong idea that we can always find algebraic solution. There are more problems that we cannot find algebraic solutions. For example, evaluate the area of an ellipsis given below. X squared over a squared plus y squared over b squared equals 1. The above is equation for an ellipse. If you can't find algebraic solution, let me know. If we can find algebraic solution, we have to use algebraic solution. But in real life application, there are more problems we cannot find or solve algebraic solutions. In such case, we have to use our algorithm to solve our equation. I will upload complete source code to my website. By the time you watch this video, you can click this link and download the complete source code. In my future episode, I will deal with more complex algorithms. Please subscribe to my YouTube channel. Thank you for watching.